In Chapter 13, we will learn about vector value functions and motion in space, where we will start from curves in space and their tangent, but in this video clip, we will focus on curves in space. Now, let's take a look. In a two-dimensional system, if we have a vector where the components are all numbers, these we call as vectors in plane. But if the components inside, they are not only numbers but they are functions, then we will say we will get a curve in plane. Whereas in a three-dimensional system, or we say in space, if we have a vector in numbers, these vectors, we call them as vectors in space. But if the components inside, they are all functions, they are not, perhaps you may contain one or two numbers, but they contain function in terms of t, for example, then we will say this type of vector, it is a vector value function and it will give a curve in space. Now let's take a look at this example. Let's say we have a vector value function in two-dimensional system where rt equals to t quarter t squared. So this one, by looking at this, imagine that we have an initial point A at 0, 0 at the origin, and then point B will take the coordinate from this vector, that is t quarter t squared. So let's take a look at this graph. When t changes, we get different vectors. So our vector changes according to the t, okay? And if we combine all the terminal points, the point B, we will get a quadratic curve. This is for a two-dimensional vector. Now let's take a look at a three-dimensional vector, the vector value function. Okay, we have, let's say, rt equals to cos t sine 2t. Well, let's use the same concept, taking the origin as the starting point, and the terminal point will take the coordinate from this vector value function. So we will see when t changes, you see the vector keep on changing the place. And then if we combine all the terminal points, we get this curve. In other words, if we have different type of vector value function like this one, this is the one that I have just shown to you just now, and this is another type, we will get different type of curves. Now, let's take a look at another example. Let's say if we have cos 5t, sine 5t, t. So this is the graph that we will get. It looks like a spring, okay, with constant radius. Well, it is formed by looking at this one. You see, we still have the origin as the starting point, and the terminal point will take the coordinate from this vector value function. So as you can see, as t changes, the b changes. The initial point remain the same. Only the terminal point keep on changing, and this type of vectors, well, it is called as the position vector. Rt is usually called the position vector, and this position vector, in this case, it is a vector value function because it can take so many infinite values, depends on the value of t. So we could see other examples. The similar vector value function, the difference is this is the same vector value function as just now. Oh, sorry, is this one. This was the one that is shown. Okay, this one, it is cos t I plus sine t j plus tk, which makes it a bit further away because it will only complete one cycle, in a longer time. Whereas this one, compared to this vector value function, okay, this one, it will having the same speed, but the problem is it will go up for in slower. So you see that the curve tends to be tighter. So these are the vector value function that you see in this video clip. You can try to explore other type of vector value function by trying some mathematical software and try to look at the curve that is generated.